Hey everybody, this is Games Plus James, and welcome to a short tutorial series on how to make a first-person shooter. So we're going to make a game that looks something like this. We're able to run around, we can open these doors, if I could actually pay attention to where I'm going. We can shoot some bad guys when they come at you, run around, get some pickups, in this kind of old retro style first-person shooter type of thing. Oh, that guy nearly got me. And you can just run around and have fun. So we're going to use a mix of kind of 2D and 3D effects, and we're going to create our levels using tile maps. But the first thing we're going to do is start off by making sure that we can move our player around in a first person kind of view. Okay, so I've started a new 2D project here, and first thing I'm going to do is import some assets that will be included in a link down below in the description of the video for you to follow along with. But you can of course use your own assets as well if you want to. But I'm just going to drag and drop these into my project folder, which opens our import package view, and I'm just going to import everything by hitting the import button. There's just a bunch of images and some sound assets and a 3D cube model that we're going to use for our walls and things like that. But to start off with, we've also got a scene here. So in the scene folder, I've got a startup scene, which just has a basic ground set up for us to use. Now, we won't use this once we start actually creating levels properly in another couple of episodes, but for now, we're just going to use this as an easy way to control our player moving around. So we've got this scene. I'm not going to save it as our startup scene. I'm going to save it as a different thing. I'm going to go to File, Save As, and then in our main assets folder, where are we? Oh, I went up too high there. In our assets folder, here we go. I'm going to go into scenes, and I'm going to save this as test. So this is where we're going to test everything out before we use it in an actual level. So first thing we're going to need is to actually be able to see what our player will see, because at the moment our game view is set up with the camera just looking down on it in a normal kind of 2D style. So we're going to have to change that. So I'm going to first of all not just move the main camera, I'm going to first of all create an empty object that will be our player, because obviously we're going to want to move the player around. Let's set them to be at 0, 0, 0. Then we're going to get the camera, and I'm going to make this a child of the player down here. So I'm going to go to like so. Then I'm going to move it into position, so it's at 0, 0, 0 as well. So we're going to put it there. Now obviously that makes the ground disappear. That's because if we switch to our 3D view, the camera is at the exact same point as the ground. So that's no good. We don't want that. So I'm going to switch back to 2D, and what we're actually going to do is move the camera slightly above the ground. So I'm going to move it to a Z of minus 0.5, like so. So now we can see the ground again, and our camera is just above the ground. But obviously we don't want our camera just looking down at the ground like that. So we're going to change the rotation of our camera, and I'm going to also change the projection. So at the moment, actually we'll change the rotation first, and we'll see why this won't work for us. So first thing I'm going to do is set the rotation on the y-axis to be 90, and you'll see immediately what happens is our ground disappears. So if I switch to 3D view here for a second, you'll see our camera, if we turn it around and look like this, our camera is looking at the edge of the ground. So we're getting our ground completely disappearing. Because we're in an orthographic view, that means it just draws the ground as a single flat point, which we can't see. So we're going to switch projection here to perspective, and then boom, immediately we can see the ground. But of course our ground is off to the side. That's not very good. We don't want our ground to the side of us. Maybe you do want that in your strange game, but generally speaking we won't. So we're going to shift on the Z-axis here our rotation to minus 90. And there we go. We now have our camera looking forward on the ground. So we've got that set up. Let's switch back to our 2D view, because we're mostly going to work in 2D over here. So now we have our camera set up. The next thing we need to do is start moving our player around. So for that, we're going to go back into our assets folder here. I'm going to create a new folder. I'm going to call this scripts. And then in here, we're going to create a new C# script that we'll call player controller, like so. I'll open this up. Let's reload this. There we go. So we've got our script here, and we're going to create some variables that we're going to use to move our player around. Now, first thing we're going to do is we're going to use Unity's built-in physics to control our player. We're going to use the rigid body system. So for that, I'm going to jump back in here for a second. We'll go to our player here. Obviously, we need to add that player controller script to the player, so let's make sure we do that here. We're also going to add a component of a rigid body 2D. Now, by default, what this will do is if I press play, it'll make our player fall down in a 2D view. So if I press play here, this is going to look weird in our game view because we're just falling off to the side. So we don't want that. So to make sure that doesn't happen, we're going to switch our gravity scale to be 0. And that'll stop us falling down, and it'll keep us, if we press play again, there we go, we're staying in the correct place. So let's then jump back into our script. So I'm going to open my player controller again. We're going to create a reference to that rigid body up the top up here. So I'm going to create here a public rigid body 2D that we'll call the RB. Then we're going to need a couple of basic things. So we need to know how fast will our player move. So we'll say public float move speed. Then we're going to need to keep track of what our player is inputting. So when we're trying to move around the world, we're going to keep track of that and then apply it to the rigid body in a certain way. And we'll see how that works in a moment or two. But for now, we're just going to create a public vector2 called move input. So this is, if you're unsure of what's going on here, a vector2 is simply a value with an x and a y value. So we'll be moving on the horizontal x-axis and on the vertical y-axis. And that's how we'll control moving around. We don't want to just control walking, we want to control where our player is looking. So when we look side to side and up and down and stuff like that. So for that, we're going to use another, oh wait, this should be a private vector2. I just realized we don't need to be able to change that within Unity. So we're going to create another private vector2 that we'll call mouse input. And then finally, when we're moving our mouse around within the world, we want to make sure that we can control how sensitive our movement is with the mouse. So we're going to create a public float that we'll call mouse sensitivity. And I'm going to set that to be 1 by default. And we're just setting this up as a thing so you can tune it for your own personal preference. And we'll also actually set our move speed by default to be 5, I think is okay. Okay, so we've got those things in place. I'm just going to save as I go. We're going to always want to make sure we're saving as we go. And what we're going to do then is go down into our update loop here, and we're going to start making sure that what we're doing is actually doing some stuff. So, because at the moment, obviously, we're not moving our player around at all. So the first thing we want to do is check what move input we're currently applying. So our move input will be equal to a new vector2, which will be saying on the x-axis, it will be input.getAxis horizontal. Ooh, I moved that. Click the wrong button there, of course. Horizontal. And on the y-axis, it'll be, you might guess, input.getAxis vertical. So now that we have some input coming in, the first thing we need to do is let's test this out by applying it to our rigid body, and we'll see what happens. On a very basic level, this is how you would do normal kind of input for moving something. This won't work properly for us at all, but we're just going to see what happens when we do it. So let's apply this movement to our rigid body. So we're going to say the rigid body dot velocity will be equal to our move input multiplied by our move speed. So however fast we want to move. So if I save this and jump back into Unity now, once it compiles, we can press play. We'll make sure actually we drop our rigid body into there, and we press play. And now if I press up, you'll see, oh, I'm moving left to right. And if I press sideways, we're moving backwards and forwards. So that's no good to us. We don't want to do that at all. I'm going to stop this. Now you might think, oh, well, what we could do is switch those around. So let's try that. Let's just try seeing what happens if we switch these the other way around. I'm just going to cut this here for a second. Like so. And we'll save this. We'll jump back in. And now when I press play, I can press forward and backwards. Oh, that works nicely. Our left and right is flipped, but that we could fix that just by switching those values around. That wouldn't be a problem. However, the problem with this is if I turn off maximize on play here, and we'll just stop and resume. If I get the player and I rotate the player, because we're going to rotate as we move around in the world. If I rotate the player like that, now when I press forward, we're still moving side to side. We're not moving where the actual camera is facing or where our player is facing. So we don't want to just apply it like that. We have to do a little bit of kind of magic to make that happen the way we want it to. So let's jump back into our script. I'm just going to undo what I just did there because we still want to know exactly what we're pressing in the right times. And what we're going to do is create 2 new vector trees down here. So I'm going to say, so for moving sideways, we're going to create a vector tree called move horizontal, like so. And this is going to be equal to transform.up multiplied by, we'll just put a move input .x for now. This is going to be something we'll have to change, but we'll worry about that later. So what this does basically is transform.up says, hey, whichever direction the transform is currently rotated to face, get the up value of that and multiply that by whatever move input we have. So we're going to do the same for our vertical input. So we're going to say vector tree for move, we're going to call this one move vertical. I'm going to set this to be equal to, this time for move vertical is going to be transform.right, and we're going to multiply this by move input dot y. And then we need to apply both of these. So here, instead of saying we're going to multiply our move speed by move input, what we're going to do is inside a couple of brackets, we're going to add our horizontal move, move horizontal. We're going to add that to our move vertical, like so, and that should give us basically what we want to happen. If I just go back in here and we'll let this compile, we're going to see one problem with this, but we'll fix that in a second or two. So now I can move forward and backwards. That works perfectly fine. When I try to move left or right, you obviously can't tell watching the video, but we're moving the opposite way to the way we want to, because the way we're multiplying it by transform.up, that makes us kind of going the wrong way, but we can fix that very easily. But the advantage of doing this is now if I rotate the player like so, now when I move forward, we're actually moving in the correct direction. So we're able to move and strafe around the way we want to. So let's fix that movement side to side being the wrong way around, and all we have to do that is on the move input.x, just hit a minus there, and it'll just move the opposite direction to whatever way we're telling it to go, because we're giving it an opposite value, a minus value instead of a plus value. So we'll press play, and there we go. We can now move around perfectly. We're able to zoom around the level. Our player's moving, but of course we're not looking around. We want to be able to control where we're looking using the mouse. So to do that, we'll jump back into our script again, and then down below where we apply the movement, like so, we're going to say we're going to control how we rotate with the mouse. Actually, I'm going to just write in a couple of comments just at the top here. I'm going to say player movement, just so we're keeping track of what we're doing, and player, let's say player view control. Very simple. Okay, so the first thing we're going to do then is say what mouse input we want to give, because we know we created the variable up here for our mouse input, and that's going to be very simply mouse input equals new vector2 input.getAxis. We're going to say getAxis raw for this one, and the axis we want to get is the mouse x-axis. So that basically tells us how much has the mouse moved from side to side since the last frame. And then we'll have an input dot, oops, hold on here, input dot getAxis raw for mouse y, like so. And then we're going to take this value that we're getting in, and we're going to multiply that by our mouse sensitivity. So this is how we can control how fast we're moving around, like so. We're going to say multiplied by mouse sensitivity, Okay, so now we know how much input we're getting in. We now need to apply that to our player. So we're going to apply to our player how fast we rotate left and right. So I'm going to say transform.rotation. So the transform.rotation that this script is attached to, which is our player, transform.rotation equals quaternion.Euler. Now, if you don't know what quaternion.Euler means, basically a rotation is, despite the fact that it shows as 3 values here, if we switch this to debug view, rotations are actually measured in 4 values, an x, y, z, and w, and that's called a quaternion. So unlike a vector tree, which will store our position, a quaternion stores a rotation. But how it's represented in Unity, when we switch to normal mode, is as a vector tree value. So we've got our rotation here. And the way we can access that in our code is, say, quaternion.Euler. So Euler basically converts a quaternion to a tree figure value, a vector tree value. So when we want to then pass in our rotation that we want to give it, well, what do we want to change? We want to change what is making our player rotate from side to side. So if we go to our player here, if I go to rotate the player, you'll see the value that changes is the z-axis value. So I can rotate from side to side like that. Let's just put ourselves back to 0. So we don't want to make any changes to the x or the y values. So we're going to say leave transform.rotation.EulerAngles.x. We don't want to change that. Transform.rotation.EulerAngles.y. We don't want to change that. And then on the transform.rotation.EulerAngles.z, what we want to do is take away the mouse input .x value. So we're taking away whatever side-to-side movement we're applying to our character. So we hit our semicolon, we'll save this, and if we go back in, once it compiles, if I hit play, I can now move my mouse side to side, and that moves the camera. So now I can use my mouse to rotate around like crazy, and we can move anywhere we want to in our little world here. Okay, so that's perfect. That's exactly what we wanted to do, but what about looking up and down? Well, we don't want to just rotate the player up and down. So if I just pause this for a second here, where's my mouse gone? There we go. If I just pause for a second, I'm going to switch to local rotation. So what I can do to rotate the player up and down, if we look at the game view, you can see, oh, I'm rotating the camera up and down. That's perfectly fine. We're looking, and it's changing our rotation over here. It's kind of changing these values kind of a little bit strangely for us because, as I said, this is converting quaternion rotations and stuff. So you can see we're not just changing one value, but let's just try it out here. If we put these at 0 and 0 again, if I change, for example, the y, that looks weird. If I change the x, that also looks weird. So we know we can't just change one of those values. But equally, if I now pull this up like this, and if I unpause, now you can see we're getting weird kind of camera movement left to right, but also the player is moving quite strangely. So now if I turn this way and start moving around, we're kind of getting weird stuff going on. The player isn't really working the way we want them to. So we don't want that going on. Instead, what we're going to do is rotate the camera itself. Or sorry, not itself, but the camera that we have displaying things. So if I just stop and play again here, and if I just pause it, if I rotated the camera up like that, and then started going, then we still get perfect rotation side to side. That works the way we want it to, and we're able to move. The way we're moving doesn't look weird, and we're not getting weird kind of strange things happening. So for that, if we jump back into our script, first thing we're going to need is a reference to the camera. So I'm going to create up here public transform. Let's call it the view cam. And then down here below where we rotate the player, we're going to rotate the view cam. So we're going to say view cam dot local rotation. And the reason we're going to use local rotation is because over here we have this rotation value here. So we have 0, 90, 90, minus 90, like so. And that's fine when our player up here is at 0, 0, 0. But if we play and we just look around a little bit, even just a tiny bit, it goes back as I move back towards this, but that doesn't matter. So we've now got a rotation here of minus 18.95, but on our main camera, while the numbers here might look the exact same, if we were to just go with normal transform that rotation, that will actually get the z minus 90 here, and it will add on the 18.5 as well. So this would actually be minus 108.95 or whatever, which is fine. But what about when we start moving things all over the place and getting weird number values? It's not something we really want to mess around with. It'll actually kind of completely mess our character around altogether. So instead, what we're going to do is work with the local rotation, which is actually just these values here. And if we use these values to move around, if I rotate back and forward like this, you can see what we're moving is the y-axis. So that's perfect. That's what we want to do. We only want to move the y-axis. So we can go back into our scripts now. And here we can say we're going to set the local rotation to be quaternion dot Euler, and we're going to say on the view cam dot local rotation dot Euler angles, like so. We're going to add a new vector tree. So rather than just setting directly the value, we're doing it a slightly bit different. We're going to add a vector tree to this Euler angles vector tree. Now we could have done this up here too, but we're just showing different ways to do the same thing. So we're not making a change to the x-axis. We've already said we want to change the y-axis, so we're going to add in here the mouse input dot y. And then on the z-axis, we also don't want to make any changes. So we'll hit our semicolon there, we'll save this, and now if we go back in, we'll hit play, and now, oh wait, we didn't assign the view cam, hold on. Try this one more time. And now we can use our mouse to move, look up and down all over the place, we can look everywhere we want to, and we've now got a basic first-person shooter movement and camera control working for us perfectly. So that's going to be it for this first episode of this series. Stay tuned for more tutorial fun coming very soon. We're going to continue on with this. The next thing we're going to do is create a way for us to actually shoot some stuff. So fire some bullets and make things look a little bit more interesting. Thanks for watching. I'll be back soon with more game tutorial goodness.